Hey everybody, this is Gorilla Typewriter here. I don't know if you've thought about it, but I've always thought that the greatest scientist in the history of mankind, down through the ages, was Darwin. He is even, in a sense, the greatest philosopher of all time. What was Darwin's greatness? The answer to the famous 3 philosophical questions can be answered in terms of the angle of advancement, but it is also almost impossible to refute them. The first question, who are you? I, an ordinary life form, evolved from an ancient single-celled organism with a powerful neuronal system. The second question, where do you come from? Answer, same as above. Third question, where are you going? Answer, you can tell from where I've come where I'm destined to go. I don't know exactly where, but it's certainly not heaven. Well, the answer to the philosophical triple question is simply and irrefutably true. Anyway, today we are going to discuss a topic that has to do with the great theory of evolution. There comes a time in our long lives when you will ask the profound question, what was the first life on Earth like? The earliest life must have been so simple that there was only a single macromolecule. Cell membranes, of course, were absent, not to mention complex, fragmentary organelles of all kinds. Take away all the non-essential elements, and all that remains is self-replication. As long as it can replicate itself, it can be called life. Some people call this replicans. There were also scientists who thought that proteins could be this replicans, and could replicate themselves, especially when prions first appeared and many people thought they had found the original replicans. However, with further study of the prion, scientists discovered that it simply denatures an already existing protein, turning it from left-handed to right-hand, and then becomes indigestible by the original protease, causing damage to normal organisms, but that the prion does not actually perform the function of replication. The familiar DNA is also an unlikely candidate for the first replicans, because DNA is very stable without the help of complex molecular biological mechanisms, and once it forms a double helix it is solid as a rock, and does not replicate itself unless given instructions to do so by a polymerase enzyme. The threshold for the most primitive life is too high to be accompanied by a polymerase enzyme, so we can basically rule out DNA. The final candidate in the race for primitive life is no stranger to us as RNA, which is very similar to DNA, but of course not ordinary RNA, which has a special name, nucleus, the nucleus of a nucleic acid, the enzyme of a protease. Because before, only proteins were eligible to be called enzymes. In modern mainstream life forms, RNA is only used as an intermediate in the process from DNA to proteins, but in the primitive stage of life, where there are no organelles, RNA has a unique advantage. Primitive life, the simpler it is, the more likely it is to exist, and scientists have discovered that RNA can catalyze itself. A biologist called Cheech was awarded the Nobel Prize for his discovery of such an RNA. An RNA called R18 allows RNA to replicate itself by 10%, and the latest TC9Y nucleus is theoretically capable of 100% self-replication, although, of course, this has not yet been achieved in practice. Such a wonderful effect, otherwise it wouldn't be theoretical. In the near future, scientists will surely design and produce self-replicating nucleuses in the laboratory, which require neither additional proteins nor the wrapping of cell membranes, and which, by chance, will be able to constantly replicate themselves, digesting all the nucleic acid fragments into their own image. The grandmother of all life, the LUCA, a last universal common ancestor. The bases and sugars that make up RNA are widespread in nature, and scientists have found these raw materials in meteorites, presumably in abundance on the distant, ancient Earth, as a food source for LUCA. Once LUCA replicates itself in large quantities, there is a chance that it will come across a wide variety of proteins and phospholipids that will ignite the evolutionary path to life. So why is there such a constant supply of these life-forming raw materials for LUCA? This relates to a concept that is often misunderstood. Some people like to explain the universe in terms of the second law of thermodynamics, which states that the universe will become more and more chaotic, i.e. an increase in entropy. But is this really the case? Not really. If you see a nitrogenous base, it probably means that there is another nitrogenous base not far away, because substances with similar properties are always born from similar environments and similar substances cluster together. Isn't that the order? Since the formation of order is a law of the universe, how can the concept of increasing entropy be applied to explain our universe? Similar environments can be on a planetary scale, such as our blue planet, where the surface has been able to allow liquid water to exist for a long time. Hundreds of millions of years of geological time, with large amounts of liquid water clustered together, so neatly and so orderly, is in itself a powerful refutation of chaos. You see a sugary substance, which means that there are plenty of sugars around, and you see a raw material for a protein, a tiny peptide segment, which means that there are quite a few peptide segments nearby. This is how primitive life had an infinite number of raw materials, and as soon as a nucleus capable of 100% self-replication appeared, the whole planet was taken over by it, and its derivative siblings of varying form. These derivatives can be encapsulated in phospholipids, and various proteins can be embedded in the bilayer structure of the phospholipids. Proteins on phospholipid membranes change the properties of the membrane, allowing certain molecules to pass easily and others more difficult, and if the selectivity offered by a particular membrane is just enough to supply the nucleuses within for easy feeding, and to block some of the harmful substances from attacking the nucleuses, then a survival advantage is gained, which can be achieved if the nucleuses generate such proteins on their own, and assemble them in the cell membrane. Preserved for thousands of generations, this is the driving force behind the continuous evolution of nucleuses. Once you know the concept of nucleuses, if a philosopher or security guard asks you where you come from, you should have in your mind the form of single-stranded RNA, our ancestor, the origin of all life. We are all children and grandchildren of it.